Hi everyone, my name is Polly, and today I'll be going over FRQ number 5 from the 2024 AP Chemistry exam. So it's right over here. Okay, found it. So this is number 5, and it's one of the shorties, so it will only be worth 4 points, but those points are really important to make sure you get as many as you can. Number 5 says, hydrogen gas and iodine gas react to form hydrogen iodide at an elevated temperature as represented by the following equation. H2 gas plus I2 gas, double-headed arrow, 2HI gas. And then also just know delta H is negative. Keep that in mind. That indicates it's an exothermic reaction. Letter A. It says write the equilibrium or the expression for the equilibrium constant Kc for this reaction. Kc is when you're at equilibrium, right? That's the values you would plug in hypothetically, and it's concentration. So you do concentration of Hi over H2 times concentration of I2. Hard brackets. They're all gases. If there was any solids, this would not have worked. But because these are gases, they're good to go. You can use all of them. And make sure that if you have a coefficient, as you see there's 2 right here, that will be an exponent for your expression. That's full credit right there. Letter B. H2 gas and I2 gas are added to a previously evacuated container and allowed to react. Uh, BI says that at a certain time, the value of the reaction quotient, Q, is 0.67. The following particle diagram is an incomplete representation of the system at this time. This diagram shows the relative number of H2 gas and I2 gas molecules, but the HI gas molecules are not included. Draw the number of HI gas molecules needed to complete the diagram. That way it's actually accurate. So, um, the one pretty easy way you can figure this out is remember they gave you Q. So remember Q is the same expression written, as bare bones. It's the same expression as the K equation, but the only difference is that Q you use values at any point except equilibrium. So this is what it says the reaction at a certain time. Q is 0.67 and Q is not equal to K at this point. So then we can just actually plug it in and figure out how many molecules of gas we have. So I plugged in 0.67 for Q, and then we're trying to solve for HI, so we leave that alone. And then we have, let's see, so for the H, 2 molecules, we have 3, 1, 2, 3. So I plugged in 3 for that. And then I plugged in 2 for the um, I2 molecules because you have 1 and 2. So when you solve, doing some quick math, that is approximately 2, and that's why I drew in 2 HI molecules. For part B2, it goes, a student monitors the number of moles of HI gas over time. Hypothesize an experimental change that could have been applied to the system in the rigid container at time t to result in the change in the number of moles of HI gas shown in the graph. Assume that the student did not add more HI gas to the system. So actually, if you go back up to the equation over here and notice, it's exothermic, as I mentioned before, and that indicates that heat is a product. So we're saying um, so basically, you can say 2 things. Why is because at this point we're kind of utilizing Le Chatelier's principle. So we're trying to figure out why are we shifting to the right? Why are we creating more HI, right? Because moles of HI is going up. So there's 2 reasons why HI could be increasing. One of them could be is that you are increasing the concentration of your reactants. If you increase H2 or I2 or both, that means that this the reactants are weighed down, and the system has to produce more product to maintain equilibrium. So that's why it's one reason why you would have to why you would have more moles of HI, or without doesn't say in the equation, but you should just kind of know that because this is exothermic, heat is a product. You could decrease the temperature, which means that the system would shift right in order to account for that loss. So either decreasing the temperature or increasing the concentration of reactants would be valid answers. For part B3 or BIII, after equilibrium is established, the mixture is transferred to a larger container at constant temperature. As a result, would the number of moles of HI gas increase, decrease, or remain the same? Again, you're using your balance equation. So notice you have 1 mole of H2 gas, 1 mole of I2 gas, and then 2 moles of HI gas on the product side. So I would say remain unchanged. There is an equal number of moles of gas, 2, as I just said. There's 2 in the reactants, 2 in the products on both the reactants and product side. There will be no shift in the equilibrium position as there is an equal proportion. So the number of moles of HI gas is not going to change because adding or doing anything isn't going to change that relative number. So that's it for question 5. Hope that was helpful. Have a great day.